So let us consider a new problem, but related to the old technique that we have been seeing, divide and conquer. Remember, one of the way things of divide and conquer was the quick sort algorithm, the merge sort algorithm, right? The matrix multiplication algorithm. In all these cases, the problem that was given to us, we always try to break it down into smaller problems, solve the smaller problems, and then combine the answers in some way to get the main answer, right? So these are algorithms which follow the principle of divide and conquer, right? So you split the main problem into smaller problems, solve the smaller problems, and put them back together to get the solution to the larger problem. That is the idea behind the divide and conquer principle. Okay. So let's consider another problem called the maximum subarray problem. Okay, maximum subarray problem. So what is a maximum subarray problem? So let's start with the basic stuff. Let's start with the definition. Okay. So consider an array, and now I am allowing variable indices. Okay, the index of the array need not begin from 1. It could begin from some number and continue up to some other number. Okay, so let's consider the array, but whose indices start from a certain value low and end at a certain value high. Okay, so low, low plus 1, low plus 2, low plus 3, up to high. Is that okay? Low plus high, and let mid. Okay, mid is the essentially supposed to be the middle part. Okay, the middle part or the middle of low and high. So how do you say it? The middle of low and high, is, so you take low plus high divided by 2. Is that right? But this could still be a fraction. Okay, so what do we take? We take the floor function. Okay, so we take the floor of low plus high divided by 2. Is that okay? So that's the middle. Okay, what is a maximum subarray? Okay, so here is the thing. Assume that the entries of A are integers. Okay, this problem does not make much sense for only positive integers. Integers which could be positive or 0 or negative. Okay, this is important. Any sign is fine. Okay, so now a sub array of A, what is it? Is an array of the form A of, let's call it E comma dot 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 comma F. Okay, what is that? Where E is obviously greater than or equal to low, and F is obviously less than or equal to high. Understand? What does this mean? Some consecutive subsequence of elements in A. Okay, some consecutive subarray. That is what we mean by subarray. Okay, some consecutive subsequence. Okay. Okay, so the entries here are E plus E, E plus 1, A of E, A of E plus 1, A of E plus 2, up to A of F. Alright. So what is a maximum subarray problem? The maximum subarray problem says the following. Find the maximum value among, what is it, some I equal to E There is some small issue. Then let me just reload this. Oh, where did it go? Very interesting. Okay, anyways. So let me repeat. Consider an array of integers a low to high, okay, with any sign, okay, positive or zero or negative. A subarray of A is always of the form A of e plus 1 up to some f, where e is greater than or equal to low and f is less than or equal to high. Okay, so what is the maximum subarray problem? Okay, so for any subarray, let's call it e dot f. You see, it is completely determined by the lower endpoint and the higher endpoint, right? E and f determines what the subarray is. Okay, let t a comma e comma f be equal to sum of all the values. Okay, sum I equal to e to f, or rather, let me just write it simply: a of e plus a of e plus 1 plus dot 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 plus a of f. Okay, that is p a e f. Okay, the question is find end values e and f such that PAEF is maximum among all subarrays. Is that clear? For any subarray is determined by the lower endpoint and the higher endpoint. Okay. So once you fix the lower and higher endpoint, this is the sum. Now you want to vary over all possible lower and higher endpoints and look at the maximum value and find out for which E and F this value is going to be maximum. Okay. This is why negative numbers are important. If you have positive, then you can only take the full array sum a1 to an summation of those. That has to be the maximum, right? But when you have negative numbers, now you cannot be sure, because sometimes upon adding some elements, that sum will decrease, sometimes it will increase. So now we want to find out for which subarray is it maximum. Is that okay? So this is the maximum subarray problem. All right. So yeah, we'll go to an example. But before that, all right. So let's consider an example. Suppose A is an array of the form, let's give some numbers: 3 minus 2, 6, 7, minus 1, 0, 9, minus 8. Is that okay? This is an array. Let's make it a little smaller. Let's have only 5 entries so that it's easier. Okay. Now, what all subarrays are possible? Subarrays, a single cell is also a subarray. Then there are 2 intervals, 3 intervals, 4 intervals, and so on. All right. So, for instance, the single subintervals, the single length 1 subarrays are the following. So, A1 equal to 3, A2 equal to minus 2, A3 equal to 6, A4 equal to 7, A5 equal to minus 1. Now, let's look at length 2. Okay, so A12 equal to, oh sorry, so the p values, okay, these are the p values. values of P. Okay, so I hope you understand when I say this. The lower and higher endpoints are inverse clear. So I'm just writing the array which I'm considering the values of P. Okay, so for instance, this is P12. That is what I'm writing to the right hand side. Okay, so so for A12, what is the value? 3 minus 2. That is just 1. Okay, A23, what is the value? Minus 2 plus 6, 4. A34, what is the value? 6 plus 7, 13. Right? A45, what is the value? 7 minus 1, 6. Okay, so yeah, I should not write it equal to. These are the values of P. Okay, these are the values that P takes. All right, so now let's look at subarrays of length 3. Okay, so A123, what is the length? 3 minus 2 plus 6, that is 7. Okay, then A234, what is the length? Minus 2 plus 6 plus 7, that is 11. A345, what is the length? 6 plus 7 minus 1, that is 12. Okay, what else do we have now? Length 4 arrays. Length 4 arrays is 1, 2, 3, 4. What is the length? 3 minus 2, 1 plus 13, that is 14. Then you have 2, 3, 4, 5. What is the sum? 13 minus 3, 10. Sum is 10. Okay, you can check. And then finally, you have the subarray, which is the full array itself, which is A, 1, 2, 3, 4, 5. What is the sum? The sum is 13. Okay, so if you look at all these values, okay, so let me give a little bit of gap. Okay, so if you look at all these values, the maximum possible value is 14, and that happens when you consider the subarray 1, 2, 3, 4. So in this case, the maximum subarray need not be unique, but in this case it is the maximum subarray of A is A1, 2, 3, 4. Is that okay? So I hope now everybody is clear about what is a maximum subarray. Okay. Now the algorithm is we need to find such a subarray. That is what we have to do. All right. Okay. So this is another example. So you can think of this as an exercise if you want. So this is a long array, 16 elements total, positive elements, negative elements. This turns out to be a maximum subarray. Okay, array A 8, 9, 10, 11. Okay, so let me write it here. Array 8, 9, 10, 11 is a maximum subarray of. Is that okay? So how do we do this? We are going to divide the problem into smaller parts. Okay, so that is why we go to this idea. So we had this. Okay, now I defined medium, so middle, right? So the middle was not defined earlier, so let me just define it now. Let middle is equal to the midpoint of low and high, so it is basically low plus high divided by 2, but now you want it to be an integer, so we fix it to be floor. Okay, this is the floor. All right, so now the thing is, for this problem we will be interested in looking at both these smaller arrays, low to middle and a middle to high. You understand? You have broken the array into two smaller parts exactly at the middle. Okay, and we will look at both of these. Alright, so how do we do that? So instead of explaining in words, here is a simple diagram. This is from the book actually. Alright. So this is the array A, low index, high index, middle. Okay, the middle box is this one, the one to the left of this bar. Okay, so what is this? Now, the maximum subarray is a subarray, right? It has consecutive indices. So there are three cases possible. That is what they are showing here. Okay, the three cases that a maximum subarray of low to high, of A low to high, is in fact contained in A low to middle. That is possible. Right? A maximum subarray of A low to high is just contained in A low to middle. Okay. A maximum subarray of this is contained just here. The other values are not important. That is one possibility. Second possibility, symmetrically, is that a maximum subarray of this A low to high is contained in just A middle plus 1 to high. Is contained in just this part. Okay. That is a second possibility. The third possibility is that a maximum subarray of this is not contained in either, but it falls in between like this. Okay, a maximum subarray falls in between like this. But here is the important thing. If it falls in between like this, then the middle box, the middle element must be in the subarray. The middle must be in the subarray. Its lower limit will be to the left of middle. Its upper limit will be to the right of limit. And we just have to find this lower limit and this upper limit. But if it is in the middle, if the maximum subarray is like this, then the middle box must be in the maximum subarray. That's the third possible case. Right? So that's what they have written here. Possible locations of subarrays of A low to high, entirely in A low to mid, this part, or entirely in A mid plus 1 to high, this part, or crossing the midpoint mid. Alright. And then further, any subarray of A low to high that crosses the midpoint mid comprises of two subarrays, A I to mid followed by A mid plus 1 to j. Right. So there cannot be any gap here. It will be A I to mid followed by some A mid plus 1 to j. Alright. That is the idea. With this, now we are ready to solve the maximum subarray problem. Is that okay? Right. So how do we do that? So now let us write down the algorithm, okay, for the maximum subarray problem. So maximum subarray, what are the parameters? A, and then the parameters low and high. Is that okay? Those are the parameters. We have the start stop commands as usual. All right. So what is this? We need to solve two things, right? I mean, what are the output? The output is the lower entry, the higher entry, as well as the lower entry, higher entry, as well as the value of the sum. Okay. So here is the thing. So the parameters will always be like this. So I am going to recurse this. I am going to ask for the smaller problem. Okay. So we will apply the same algorithm recursively, maximum subarray of the smaller problem. All right. So let's first define middle equal to in the algorithm. So floor of low plus high divided by 2. You have that. Now, what are the values that we want? So for the left part, so I'll call them left low, comma, left high, left low, left high, left value, left value. These are the outputs to be given. Maximum subarray of what? A, low, and middle. Understand? Because that is the left part, right? So the smaller algorithm, the smaller array that you have, apply the maximum subarray, whatever is that algorithm, to that. Is that okay? Right. Secondly, do it for the right part also. So you have now right low, right high, and right val is equal to maximum subarray of A, mid, and high. See, now what is the issue here? When you're calculating these, you're going to a smaller problem, but somewhere you have to halt, right? So the base case is what? Base case is when the array itself is singleton. That is when you have to say what it is. So the first thing that we need to check is if low equal to high, then you simply return, what is it? It's just one value, right? So it is just low, high, and A of low, because A of low is the only value that you have. That you have already done. And then all of this that you're writing is inside else. Okay. Right. So we have this. What else do we need to calculate? We also need to calculate the middle part. Okay, the crossing part, the part that crosses the middle. So let's call it cross low, cross high, cross value is equal to. Now this algorithm is slightly different, right? So let's call it maximum cross subarray. Why is it different? Because we don't need to calculate this again. It's of a different kind. So let's just look at that. Low, mid, high. Okay, we will pass all three. Is that okay? All right. Now assuming that we have all these possible values, assuming that we have all these possible values, what should we do? We are just supposed to find out the maximum among these three values, right? Because this is the maximum subarray from the left part, this is the value of the maximum subarray from the last right part, and this is the value of the maximum subarray from the crossing part. So whichever is the maximum among these three, you return that. Is that right? Okay. So now you know how to compute maximum of numbers. So we just say if, so how do you say? Left val is greater than or equal to right val, then you still have to check, right? If left val is also greater than or equal to cross val, I'll just make it smaller because I need more space. Okay, but I hope you can read this. If left val is also greater than or equal to cross val, then the left part has the maximum subarray. So you just return this thing: left low, left high, left val. Now, if this is not true, we have already seen this. Then cross val is greater than left val. Left val is also greater than right val. So the cross val is going to maximize. So you return this couple: cross low, cross high, crosswise. Okay, that is the end of here. But then you have another else, right? So else, what is it? If all right, so I just leave it to you. Okay, instead of me writing the whole thing down, I'll just leave it to you. So this is your exercise. Now you got an idea of what you want to return. I just want to compare the maximum of these three values and then find out. We have already done this. Okay, so I'll let me not repeat. The else part, just write it on your own. Okay. Now what cases remain in order to do this? So just follow this idea and this will complete this algorithm. But note, in maximum subarray, we used two smaller maximum subarrays, which is recursion. But there is also this maximum cross subarray that we have not defined. So this algorithm is remaining. Okay, this algorithm is remaining to be written down. Is that okay? So let's do that. So let's write this algorithm. So let me do it in the next page. So what do we already know? So this is maximum cross subarray. We have a, low, mid, high as the parameters, right? Okay. Now we already know that whenever you're looking for a cross subarray, it will always contain the middle, the middle element and the middle plus one element. Is that right? So I will set I is equal to middle, j is equal to middle plus one. Let us set this and let us set sum is equal to a of I plus a of j, right? The first sum that we need to take. Now, in order to find out the subarray that crosses, all we need to do is we need to take I to the left and j to the right and see when we get the maximum possible value. I to the left, j to the right, when we get the maximum possible value. Is that okay? Right? So that is again very, very simple to see. So what do we do? Now it's just a while loop. Okay. So while the first thing, let's do it on the left hand side. While sum plus a I minus 1, if you move one place to the left, if this gives you a greater value than sum, then I want to move I to the left. I want to include that element, right? Then I is equal to I, sorry, I is equal to I minus 1. Further, sum is equal to sum plus a I minus 1. I have included that element. Okay, because including that element to the left of I, the I minus 1 element increases the sum. And I'm looking for the maximum subarray. So I include that element. All right. I keep doing this continuously until I keep getting the greater and greater values. At some point, I'll stop. For that I, when I look at I minus 1, the sum will not increase. Therefore, I will stop at that I. I will not decrease it any further. Is that okay? So that is then end while. That is what I'm doing. Similarly, for the right side, while sum plus a j plus 1, because j is now going to the right, is greater than sum, I'll do j is equal to j plus 1. Oh, sorry. Just a small confusion. So this has to be done first, right? Because I am adding the value and then changing the index. If I change the index beforehand, then the values will change it. Okay. So that's the small correction. So again, here the same thing. Sum is equal to sum plus aj plus 1, the larger value, and then j pushes to the right. Okay. And that is the end of the while statement. Then what do I do? I am done. What is the value that I'm returning? I'm simply returning this while loop stopped at the correct values of I and j, right? And the sum is recorded in the variable sum. So I just have to return the tuple I, j, sum. Is that okay? I just return the tuple I, j, sum because I stopped at the left end where the sum is getting maximized. J stopped at the right end where the sum is getting maximized, and the variable sum is recording the maximum value of the sum. And these are the three values that I want to return. Okay, so I have returned. Okay, so that completes the cross subarray algorithm, and this we have already done. Okay, so please complete this. This is just again comparing the remaining cases and then returning appropriately. Okay, so it's a very simple exercise. So that completes this basic algorithm for finding maximum subarray problem. This is again a divide and conquer algorithm. Why is that? Because of this reason, we are dividing our array into smaller parts. We have divided it basically into half pieces and use the same algorithm on the smaller pieces first. And then there is this additional case. There is this additional case of the middle part, which we can fairly easily handle with this additional algorithm. Okay, so that is the solution to the maximum subarray problem. All right, so yeah, so that's what I had to say. I'll stop here now.